Imagine this. Billions of years ago, the early solar system was a chaotic place, a cosmic shooting gallery of dust, gas, and rock. Planets were still forming, crashing, and reshaping themselves in violent collisions. Asteroids slammed into worlds with unimaginable force, ejecting mountains of rock into the dark, endless void. Now, picture a single fragment from one of those impacts, a small piece of a world, drifting through space for eons. Locked inside that rock, deep within its pores, shielded from the radiation of the sun, might be something truly extraordinary, a microbe, a tiny speck of life, asleep, waiting. Could that ancient traveler, that microscopic hitchhiker, have crossed the gulf between worlds? Could life itself have spread naturally from one planet to another? This idea, as wild as it sounds, has a name: Panspermia. It comes from the Greek words pan meaning everywhere, and sperma meaning seed, literally, seeds everywhere. It's the hypothesis that life, or at least the building blocks of life, can travel between planets, moons, or even star systems, carried by rocks, comets, or cosmic dust. Panspermia isn't just an old myth, it's a serious scientific question. We already know that material moves freely around our solar system. Every year, tons of space dust and small meteorites fall to Earth. Some of them are billions of years old. And here's the incredible part. We found meteorites on Earth that came from Mars. These Martian rocks were blasted into space long ago by massive asteroid impacts. Some of those fragments drifted through space for millions of years before landing here, carrying chemical fingerprints of their Martian origin. So, interplanetary transport, the shipping of rocks between planets, is not hypothetical. It happens. If rocks can move between worlds, then the next question is, could life move with them? Space is harsh, almost unimaginably so. There's no air, no water, intense radiation, and extreme temperatures. Yet, life on Earth has proven to be incredibly tough, far tougher than we once believed. Certain microbes can survive conditions that would kill nearly everything else. Bacteria like Deinococcus radiodurans can endure doses of radiation thousands of times higher than what humans can tolerate. Tardigrades, those tiny water bears, have survived in the vacuum of space, enduring freezing and radiation for years before being revived. Even fungal spores and bacteria exposed on the outside of the International Space Station have survived for extended periods, shielded only by thin layers of dust. If such organisms were trapped inside a rock, where they'd be protected from radiation and temperature swings, it's plausible they could survive the long journey between planets. Some scientists estimate that a rock ejected from Mars could take anywhere from a few years to a few million years to reach Earth, and in laboratory tests, dormant bacterial spores have remained viable for millions of years when properly shielded. So, in theory, panspermia is possible. If life did travel between planets, where might it have started? One popular idea is Martian origin, sometimes called the Martian seed theory. Billions of years ago, Mars was a very different world. It had rivers, lakes, maybe even shallow seas. Its atmosphere was thicker, and it had a magnetic field that protected it from radiation. In short, Mars may have been habitable, possibly before Earth was. Earth, at that time, was a chaotic molten world, frequently bombarded by massive asteroids that sterilized its surface. But Mars, smaller and cooler, might have offered a calmer refuge for life to begin. If microbes arose there first, it's not hard to imagine them being blasted into space during an asteroid impact. Some of those Martian rocks, carrying life, could have landed on early Earth, seeding it with biology. If that's true, every living thing on our planet today would share a Martian ancestry. In other words, we might all be Martians. Of course, the opposite could also be true. Maybe Earth was the first place where life appeared, and fragments of our world were launched into space, carrying microbes outward. Large impacts on early Earth could have easily ejected material into orbit, some of which might have reached Mars, the Moon, or even the icy moons of Jupiter and Saturn. If any of those worlds had the right conditions, water, energy, and stability, then maybe some of those microbes found a new home and continued to evolve. It's a breathtaking thought. Life from Earth quietly spreading across the solar system, invisible to us, yet alive. Some scientists push the idea even further, suggesting interstellar panspermia, the transfer of life between different star systems. It's a bold concept, but not impossible. Tiny grains of rock and dust can drift between the stars, propelled by radiation and stellar winds. If microbes can survive those journeys, and if even one speck finds its way onto a habitable planet, life could spread throughout the galaxy over billions of years. That would mean life might not be rare at all. It might be part of a vast, interconnected biological network, seeded from one ancient origin and scattered among the stars. So, how do we find out if panspermia really happened? That's where modern exploration comes in. NASA's Perseverance rover is currently exploring Mars, searching for signs of ancient life, fossilized microbes preserved in rock. If we ever discover life on Mars, the next big question will be, is it related to us? If Martian life uses DNA, or the same 20 amino acids that Earth life does, that would suggest a shared origin, strong evidence for panspermia. But if Martian life looks completely different, if it's built on different biochemistry, then life might have started independently there. That would mean life isn't just transferable, it's inevitable. Either answer would be revolutionary. Panspermia doesn't explain where life first began. It just shifts the question to another place. If life came from Mars, then where did Mars get it? Maybe it started there, or maybe it came from somewhere even farther away. Perhaps a long-lost planet orbiting another star billions of years ago. This cosmic chain of life, from world to world, system to system, paints a universe not as dead and empty, but as vibrant and connected. Maybe the seeds of life are constantly moving, waiting for the right planet, the right moment, the right conditions to awaken. And if that's true, then the story of life on Earth isn't just our story. It's part of a much larger one, a story written across the cosmos, in dust and stone and time. So, could life have spread between planets naturally? We don't yet have proof, but every discovery brings us closer. We know rocks travel between worlds. We know microbes can survive the vacuum of space. We know early Mars and Earth both had conditions that could nurture life. When you put all that together, panspermia isn't just possible, it might even be probable. And maybe, just maybe, the universe has been alive far longer than we've ever imagined. Maybe every world is connected by invisible threads of biology, linking us all back to one ancient spark, one cosmic seed that began it all. Life, after all, finds a way, even across the stars.